Right, today we're going to be talking about how to dilate the equation of a line, specifically when the center of dilation is one of two things, either at the origin, which there will be a rule to know, or if the center of dilation is on the line, which there will be a different but similar rule to know. So at this point, we would like you to pause the video and try number one. This is it right there. Write the equation of the line, the image after you do that dilation. So pause the video, complete it. Welcome back. Now we will do this dilation. So I'm going to graph my center of dilation. It is right there. And then I'm going to dilate line AB. But I guess first I'll write the equation. And all the equations are y equals, and then we're going to fill in the slope and the y-intercept. So my slope is simply rise 1 and run 1, both of which are positive. So if I want to, I could put 1 over 1. This is just like 1x, and heck, I could even leave it as x. I guess I'll put it as 1 over 1x. And then the y-intercept is positive 1. So I will also put that in. And now I'm ready to do my dilation with a scale factor of 3. So I'm going to do the visual method where it's like, let me do the green. Over 1 up 2. That's 1 time. Over 1 up 2. That's 2 times. Over 1 up 2. That's a dilation of 3. So B prime will go right there. And then for A, it's down 1 and to the left 2. So that's a dilation of 1. If I repeat it a second time, it's a dilation of 2. And a third time is a dilation of 3. So A prime would go right there. Now I'm going to erase all of my kind of construction marks. We're going to draw in our line. Oops. There's A. We're going to draw in our line from A prime to the B prime. And we can pretty clearly see that the y-intercept is 1, 2, positive 3. So when I go to write my new equation, it's going to be that y equals in x and then plus 3, and we'll fill in the slope in a second. And if you remember from yesterday's lesson, you know that slope is going to be the same as my original, because dilations always produce parallel figures. Dilations produce parallel figures. Okay. And if you just want to verify that, it's up 1 over 1, that plus 1 and plus 1. It's the same. The only thing that's changing is this y-intercept. And that brings us kind of to our next case here. Pause the video and try out number 2 and number 3. Alright, so you should be back now. And you can talk about the slopes. What happened to the slopes? Nothing. Nothing happened to the slopes. Stayed the same. And that's because dilations will produce parallel figures. And parallel lines need the same slope. That's why slope stays the same. Now the y-intercept, on the other hand, the original was plus 1. And the image was plus 3. So what's happening from original to image is that it's getting multiplied by the scale factor. So the scale factor was 3, so when we multiply that, that's how we're getting the dilated y-intercept. So if you want to put this in words, what's happening to the y-intercept? Here it is. Y-intercept is multiplied by scale factor. if you need time to copy notes, pause the video, and you can take as much time as you'd like. We're moving on. So today we're going to talk about how to write the equation of a line when it's dilated about the origin. That would be one rule, and about a point on the line. That would be second rule, but even easier than the first. So here is the first concept we're going to look at. I would like you to pause the video and look at this diagram and try and fill in those blanks based off of what you see. So go ahead, pause the video and try. Okay, so coming back, if you look here, the original is the blue, the image is the red, and when we dilate a line about the origin, the image will be parallel. I swear it's there. Is it not? Apparently not. The image will be parallel. Okay. That means that they will have the same slope or equal slopes. And you can kind of see that right there. There's supposed to be an x there, and there's supposed to be an x there. The slopes are negative 1/3 and negative 1/3. They are the same because they're parallel. But the y-intercepts change. The y-intercept went from 2 to positive 6, and that's because we dilated with a scale factor of 3. The capital D is dilation, and then the 3 subscript tells you the scale factor. This is the scale factor. So the y-intercept will be multiplied. Oh, I did write that there. Apparently not. Multiplied by the scale factor. Okay. And if you want to see an example of that, we have our line there. There it is. This one has a slope of negative 1/2. And if I dilate, so I'm just going to clear out my cursor. Sorry. Edit, undo. I'm going to dilate this line about the origin, and then I guess my scale factor will make it a scale factor of 3. And when we do that, there's the new line, and I'll color it red. Boom. And you can see the slopes stay the same, but the y-intercept changes, gets multiplied by the scale factor. Okay, and let's go back to our notes and let's apply this. Yeah, so let's use our notes and let's try example 1. So you pause the video, use your notes, and try and fill it in. Okay, so here we can see if we annotate, there's our equation. It is a dilation, scale factor 3, and then I think one of the most important things is the origin. All right, so when we dilate about the origin, the image will be parallel. They'll have the same slope. This equation is nice and neat. It's in y equals mx plus b form. So we're just going to take that slope and write it down. And then this y-intercept, it's going to change. It's going to get multiplied by the scale factor. So we have plus 5 times our scale factor. So right, it's like the original y-intercept times the scale factor. And that's going to give us 15, the dilated y-intercept. And that's a positive, so it's plus 15. That's what you should get for that. Okay, so now the second concept is when the center of dilation is on our line. Okay? When the center of dilation is on our line, if you look at this picture, what do you notice about the original red line and the image of the green line? Are they different or are they the same? And if you said the same, that is correct. If I told you the equation of a line of the original is y equals 2x plus 3, then the image would literally be the same. Y equals 2x plus 3. And that's the rule. When the center of dilation is on the original line, then the image has the same equation as the original line. The line does not change. Line does not change. Okay. And if you want to see why that is, we'll come back to here. Here's a new point C, and I will put that point on the line. And I will clear my cursor. I will dilate this blue line about that red point. And honestly, the scale factor does not matter. So I will make a scale factor of, I don't know, 4. And that might be too big. Let's do 2.5. Okay. And you can see the dilated image, this one here, which I'll turn. How do I get the color? Oh, I know why. What's going on? There we go. Let's turn it orange. Now we've got this second orange line. It's just on top of the blue line. If I hide it and show it, it's right on top of the blue line. And that's because that point C is on the line. If I move it to the origin, it lines up with our red. Oh, I changed the scale factor. That's right. It moves off, right? And it moves predictably to where it's supposed to be. If our y-intercept is 2, and my scale factor was 2.5, 2 times 2.5 is that y-intercept of 5. Okay, and it still has the same slope. Okay, but if I put it back onto the line, the equations are literally the same. Literally the same. You might be saying, why? Why is this? And that's because the way dilations work is if this is I don't know, pretty darn close, whatever this distance is, then the image needs to be that far away on the other side. So if it's a distance of 2 away, 2.5, that's right, because I picked 2.5 for the scale factor. It pushes the image 2.5 away. But as it gets closer, that distance goes to 0. And when it's 0, 0 times 2.5 is still 0. So the image needs to be a distance of 0 away. If I put it a distance of 1 away, then I know this distance from the line to the line will be 2.5, because that's my scale factor. And I guess I'll show that to you. If I made a segment from there to there, that distance is 1.5, because the total distance is from here to there. That would be the 2.5. Okay. Short story, the summary is, when the center of dilation is on the line, the equations are the same. The equations are the same. Okay? Equations are the same. You might be saying, well, how can you check if a point is on the line? The quickest way is to substitute. Substitute point into equation. Okay? And I guess we'll show you that in example 2. But first, you're going to pause the video, and you're going to solve for y. You're going to solve that equation for y. Because Because when you look at that equation, you can't tell the y-intercept. You can't tell the slope. All right? Okay. All right. Now, I know I told you to solve for y, but I kind of want to illustrate right off the bat that this point, this x and y, is on that line. Because right now it's written real nice. My x value is supposed to be 3. I'm going to copy that minus 3, and then instead of y, I'm going to leave it open, and I'm going to substitute in this y at negative 3. And all of this needs to equal at 15. If I do this math, that's 6. That's a negative times a negative is a positive. And yeah, in fact, 6 plus 9 is 15. So this is how you can verify that a point is on the line. And once you verify that your center of dilation is on the line, the answer to this question, write the equation of the line's image, it's literally the same equation. The answer to that is the same equation. So, I mean, theoretically, you could just copy that equation. Okay? But if they said, you know, identify the slope or the y-intercept, that's where solving in y comes in handy, and especially on like a multiple choice. So to kind of check in with you, when you solve this equation for y, you want to isolate your y. And I know there's a negative 3 there first, but we got to get rid of this 2x. And we're going to subtract 2x. Whatever you do to one side, do to the other. And you're going to have this minus 3y equals minus 2x plus 15, because that's a positive 15. And this is good. This is looking like y equals mx plus b. It's just we've got this minus 3, and we want to get rid of that. And that's why we're going to divide both sides by minus 3. And everything gets divided by minus 3. So those will cancel. We'll be left with y equals. The negatives will cancel. And all we'll be left with is this 2/3. And fractions are nice because this is our slope. The thing in front of x is our slope, and then our y-intercept is at the end. 15 divided by negative 3 is negative 5. So you probably on like a multiple choice will see this as your answer, and you just have to realize that this equation is literally the same as that equation. Alright, so let's do some practice now. We've got some practice problems here, and we are going to tell you to pause the video and try problems 1 through 5, and then come back when you're done. Okay, so in here we're going to do just 2 problems, I guess. We'll do a problem where the dilation is about the origin, and we'll do a problem where the dilation is about some other random point. So we'll do 4 and number 1. So when you're doing these dilations, you want to annotate. You want to know which rule is it. Is it the rule where it's about the origin, where it's same slope but multiplied y-intercept? Or is it about some other point? And spoiler alert, when it's some other point, it's just the same equation. You don't even really, it's the only way they ask the questions on the regions. So, for number 1, I annotate and I say, okay, look, it's about the origin. So what's important is this scale factor 4 and my equation. That equation's nice and neat. It's y equals mx plus b. So I can see that my slope is next to x. It's the 4. So when I go to write my dilated equation, it needs to be parallel. They have to have the same slope. But this plus 3, right, that plus 3 is going to get multiplied by my scale factor of 4. So my new y-intercept, right, the image, it's going to be 3 times 4, which is 12. So I'm going to stick that positive 12 at the end. And you should have some work showing, like, you know, your calculation for the y-intercept. So 2 is literally the same thing, but now you're multiplying by 1/5. And number 3 is where it gets a little bit tricky. I'll give you a hint. This you have to first solve for y. That way, when you have it as y equals, whatever you have in front of x, that's your slope. Whatever's at the end, that's your y-intercept. So that the dilated figure, it's going to be y equals. You're just going to take this slope and put it there. And then this y-intercept, yeah, it's going to go at the end, but it's going to get multiplied by your scale factor. So it's going to be times your scale factor. And in this case, it will be 5 of whatever you found for the original y-intercept. Okay. Now, number 4 is what I think the easier one. Whenever it's a dilation about some other point, that point is going to be on the line, and your answer is literally the same equation. This would be your answer. Y equals 4x plus 3. But if you want to verify that, points are in the form of an x and a y, and you could substitute that 7 in for y. So instead of y equals 4x plus 3, I could put a 7 for y. That's y. I could delete that x, and I could multiply by 1. And then 7 is supposed to equal, well, 4 times 1 is 4, and then plus 3, yeah, 7 is 7. That's how I know it's on the line. And then once you see that, this is your equation. You're just copying. It's the same equation. Okay. You could try out number 5. And then at this point, you're going to pause the video, and you're going to finish the page. You're going to finish the page. Okay, so for this one, we will do 2 more problems. We will do number 8 and number 9. And I want to see what you guys put down to 10 and 11, so I'll let you kind of show me that. I mean, if you're looking for like a cheat sheet, there it is. General rules for dilation of a line. You can pause the video and copy that down if you want. Okay, so for number 8, I'm going to annotate, I'm going to scan, I'm going to be like blah, 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 blah. Oh, centered at the origin. That means same slope, but multiplied y-intercept. Okay. So my scale factor is important. And let's see, here's my equation. So we got to solve this for y. I'm weird. I like my y's to be positive, so I'm just going to add y to both sides. And I'm going to get 3x equals 4 plus y. I'm going to bring this to like a new line. And I'm going to say, okay, well, I'm still solving for y. So now this 4 is bothering the equation. So I'm going to subtract 4 from both sides. 3x and negative 4 don't combine, so I'm just going to copy it down like 3x and then minus 4. And that all equals y. And because equal signs go both ways, I'm going to put that y there, and I'm just going to copy this to the back. And now I have a nice y equals, and I can see that my slope is 3 and my y-intercept is negative 4. And if I follow my rule, right, my answer is going to have the same slope. This slope It's just literally going to go there. And then this y-intercept, it's going to get multiplied by my scale factor. And it's going to turn into -8. And that multiplied scale factor is my new y-intercept. And this would be the equation that is a dilation of 2 of our original. And then in number 9, I'm going to kind of scan it and say, all right, so blah, 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 blah. All right, it's a dilation. Yep, there's a scale factor. And the point is -1, 9. Okay, so this is not the origin. All right, when it's not the origin, it's the same equation. Okay, you can literally just copy this. This is your answer. 3x plus y equals 6. But if you wanted to, you know, put it in y equals mx plus b form, all right, we could do that. We could do that. So we'll solve this equation, right? 3x plus y equals 6. Y is positive, so I like that. I'm going to subtract 3x, subtract 3x. I got y equals minus 3x, and then that's a positive 6. And here I can see, okay, great. Here is my equation that is now in y equals mx plus b form. And if you're still skeptical about this, you're like, well, you know, what about that point? Is it on the line? Sure, let's substitute x and y. So this is 9. We're going to have -3 times -1, and then plus 6. And, well, -3 times -1 is positive 3. And that positive 6 will give me 9. And 9 does, in fact, equal 9. And that's how I know this point is on the line. And you might be saying, look, doesn't that scale factor matter? No. Not when the point, the center of dilation, not when that center of dilation is on the line. It just won't matter. And I'll give you another example. I will dilate my original blue line about point C, and I'll make the scale factor something ridiculous. I'll make it 1,000. I'll make it 10. Okay? And here is that new image. Okay, right here. And I'm going to make it green this time. And there you go. You can see that even with a dilation of 10, that line is still on the original. Now, if I move this center of dilation off the line, right, if I take C and I mean, now it's going to get pushed really far away. So if I put that, you know, if we follow our rule, like the original line has a y-intercept of 2, then if I put C at the origin, that y-intercept is going to jump to 2 times my scale factor of 10, to 20. So I'll show you that. C is going to move to the origin, and now that line has a y-intercept of 20. And if I were to like literally zoom out, you can see that new line hits 20. But when I put that center of dilation back on the blue line, let me try my best to get it right where it's supposed to be. I'm like zoomed out, but you can see it's going to land back on the line. Okay, if I were to zoom back in and then put that center of dilation on the line, the equations are the same. So I hope this was useful. If you have any questions, please ask me. I will be floating around the room helping you guys out. I appreciate it. Have an awesome day.